Okay, today in IM2 we're going to learn about graphing a factored quadratic in intercept form, and this is section 3.5. So if you look at intercept form, it's the same as factored form, and it's important that you know what you can get. So let's ask, what can we tell from just looking at the factored form? Well, we can tell if there's a reflection, if A is positive, okay, positive A, no reflection, and negative A is a sad face. We can tell that it has two intercepts. Okay, we can't tell what kind they are, but it gives us the two intercepts, the x-intercepts. Remember that the different names for x-intercepts that you will find as you study quadratics is x-intercepts, solutions, roots, and zeros. These are all names that you'll come in contact with as you go through different books and different videos. Okay, so in this exploration in the journal, they are being very basic. They're just asking you to say, is this a positive or is this a negative? But we're going to delve a little bit deeper into this so we can explain things a little bit better. But we'll do the first ones just like they asked us to. So the first one I can see is that I have a positive graph and I have two positive intercepts. So I'm just going to write the f of x, but I'm going to add an a, because we know that a tells us whether it's positive or negative, x minus p, x minus q. And the a also tells us if there's a stretch or shrink, but for now we're just going to leave it at this. When we have a positive intercept, our formula will have a minus here, okay? Because that means that this is a positive value. Over here we have a negative graph, so that means when we write this, we're going to have a negative a, and we have two positive intercepts again, so we have x minus p and x minus q. And the p and the q just represent our factors, nothing more than that. Okay, in the second example, it changes up a little bit. We have one intercept that's a 0 and one intercept that is positive. We have a positive graph. So when we write this, we're going to go the f of x equals positive a, and then we're going to go x minus 0. I'm going to go left to right with these intercepts, and then x minus q. And I can simplify this to just ax, x minus q. So when you see a function or a quadratic that is in this form, you'll see that we have, it's a positive. We don't know if there's a stretch or shrink because we don't know what a is, but there's one intercept that's 0 and one positive intercept. Okay? Over here we have another positive one. We have one negative intercept and one that equals 0. So we're going to go f of x equals a, and this time when we put our p in there, we're going to say it's a negative p. It's a negative intercept. And then we have x minus q. And so if we simplify, we get a x plus p and x minus q. And when we see this, we'll recognize that we have a negative intercept, okay, negative intercept, and one positive intercept. Okay, now we're going to look at this one. We have a negative graph, we had one negative intercept, and we have a 0 intercept. So going left to right, we're going to say the f of x. We have a negative a, we have an x minus negative p, and we have an x minus 0. And so that means it's going to simplify to negative a, x plus p, and now we've got this x here. And we don't want to leave that there, so we're going to rearrange using commutative property until we get this. Okay? Over here we have one intercept that's 0, we have a negative graph, and we have a positive intercept. So this one's going to be the f of x equals negative ax. We already learned what happens when we have a 0, so I'm going to quickly do that. And then x minus q. Alright, for this one, we have a negative intercept and we have a positive intercept. So what are we going to do here? So we have we have f of x equals, this is a positive graph, so a, and then we're going to go x minus negative p and x minus q. That's a positive there. And so we get a x plus p and x minus q. So we can see that we have one positive and one negative. Okay, over here we have a negative graph with one negative intercept and one positive intercept. So it looks like this, f of x equals a, and we know that it's going to be zip-zap, so we're just going to put x plus p. We forgot our negative. Don't forget your negative. It's a negative graph. And x minus q. So you can see the differences between the two. And I think that gives you a little bit more of an understanding of what they were getting at when they asked you to do this. Okay, this is telling you that if you want to graph using the intercept form, you start by finding the axis of symmetry by finding the average of your two intercepts. Okay, you can also look at the graph in this form and know right away if it's a happy face or a sad face, and that gets you started in the right direction. Okay, I really like this example from the book, and it's going to show us how to go through the steps to graph using the intercept form. So the first thing you do is you find your zeros, or your x-intercepts, and you get those straight from your formula. Okay, we also keep in mind that we have a negative graph, so we want to maybe put a little notation to ourselves. Then we take those, and we're going to find the average of those, -1 plus 5, divide by 2, and we're going to get our axis of symmetry. There it is. And so that would be x equals 2. So that's our first step, but what do we do then? We're going to take that, and we're going to plug it into this formula, and we're going to get the vertex. So there we go. So we find it, we plug that 2 in for x, and then solve it, and that gives us a y of 9, which gives us the vertex of 2, 9. So now that we've done that, we've got a graph, and we've got the parabola started, but in order to make your parabola more accurate, you want to have a couple more points. So the quickest thing to do is to take that formula that they gave you in intercept form and just simplify it. So we're going to multiply it all out. So negative x squared minus 5x plus 4x is negative 4x minus 5. And then we're going to distribute the negative, negative x squared plus 4x plus 5, and that gives us our y-intercept, which is right there. And then we have another point, the near point over here, and now we have our 5 points to make the graph even more accurate. Okay, so let's identify the x-intercepts, the axis of symmetry, and the domain and range for each of these points that we have here. So we're just going to go through them in practice. So we've got number 2, our x-intercepts are 2 and 3. We're going to divide that by 2. We get 5 over 2, so our axis of symmetry is 2.5. Okay, and then we're going to go ahead and do the vertex. So we're going to go y equals, because we need the vertex in order to find the range. So we're going to go ahead and do that. And we take negative 3. I'm going to put the x in there, 2.5 minus 2, and 2.5 minus 3. And then we get negative 3 times 0.5 times negative 0.5, and that equals y equals 0.75 when you multiply it by 3. So now we know that our vertex is 2.5 and 0.75, and you can convert those into fractions, it doesn't matter. How do we find the domain? Well, because this is a regular quadratic, we know that the domain is all real numbers. Okay, our range, on the other hand, is limited by, this is a negative graph, so it's a maximum, so we know that our range is going to be less than our maximum. So range is less than or equal to 0.75. All right, Let's switch colors and do number 3. So for number 3, we have our intercepts are negative 5 and negative 1. We're going to divide by 2, negative 1, sorry. Going to divide by 2, and we get negative 6 divided by 2, and that is negative 3. Okay? So now we have an axis of symmetry of x equals negative 3. We're going to plug that into our formula. Negative 3 plus 5 times negative 3 plus 1, and we get 2 times negative 2, and that equals negative 4. So our vertex is negative 3, negative 4, and this is a happy face graph, so this is a minimum. So our domain is all real numbers, and our range is y is greater than or equal to negative 4. So this was number 3. Okay, if you want to push pause here and try to do the next one on your own, go for it. Otherwise, just hang out and we'll do it together. Okay, here's number 4. So our x-intercepts are 3 and 1, and then we divide by 2, so it's 4 over 2 equals 2. Okay, then we're going to plug that in. Remember, we have a downward facing graph this time, so it always makes a difference. So we go negative 4, we go 2 minus 3 times 2 minus 1, and we have negative 4 times negative 1 times 1. And so that equals 4. Okay, so our vertex, and they didn't ask us for this, but I like to always write it, is 2, 4. And our domain is all real numbers. And our range, because it's a sad face and it's a maximum, is less than 4. So our range is y is less than or equal to 4. Make sure that you use a y when you're describing the range. Okay? All right. So here's the answers. You can check. And there we go. All right. So our last step in this graph, or in this video, is to graph this one. So we're going to start by finding our intercepts, which are negative 3 and positive 1. And we're going to divide by 2. So we go negative 2 divided by 2 is negative 1. So our axis of symmetry is x equals negative 1. So first thing I'm going to do is I'm going to go ahead and graph that. Okay, then I'm going to take the negative 1 and plug it in. Negative 2 times negative 1 plus 3 times negative 1 minus 1. And this is negative 2 times 2 times negative 2. And that equals positive 8, because it's a negative times a negative, and 2 cubed. So my vertex is negative 1, 8. So I'm going to do these by 2, so 2, 4, 6, 8. This is my vertex. Okay? This is my axis of symmetry. And that is x equals negative 1, and this is negative 1, 8. Okay? So now I'm going to put my intercepts on there because they gave them to me. So the first one is negative 3, 1, 2, 3, and the other one is 1. Okay, so now I can look at my axis of symmetry and say, yay, it's right in the middle. But I want my graph to be a little bit more accurate. I want to understand the shape a little bit. I don't want it to be pointy. So what I'm going to do is go negative 2 times, and I'm going to FOIL this part, the intercept part, and I get x squared minus x plus 3x minus 3. Negative 2 times x squared plus 2x minus 3. And now I'm going to distribute negative 2x squared minus 4x plus 6. And now I know that my y-intercept is 6. So I'm going to go 2, 4. There's my y-intercept. And I have a mirror point that's the same distance on the other side of the axis of symmetry right there. and then I'm going to graph, and my graph should look like that. And there you go. So that's how to graph using the intercept form, and I hope that that helps you with your homework. Have a great day.